Welcome back. Now we're looking at loops. So here's a couple different while loops, and as before we've got our same kind of basic ingredients. We've got some expressions and a Boolean condition and code inside the loop. This is kind of how we do them in assembly. So we check our condition, okay, we set some flags, we conditionally branch to test whether or not we sort of break out of our loop, and if we don't, then we do the loop and we branch back here and do it all again. So what does this look like in assembly? Well, something like this. So we set our flags with like a comparison instruction, then we either do our loop code or we escape our loop. Here's a little example code. So while x is not equal to 5, we're going to divide x by 2. So we'll use register 0 for x, and we'll put a number in here. 15. Okay, coolio. We'll demonstrate this loop. So we have the number 15 in here. Now I've set this to decimal format just to keep things nice and easy to understand. So we've compared register 0 and 5, so 15 and 5. And NE is our not equal condition. So is 15 equal to 5? Nope, it's not equal. So we'll take the branch and do an arithmetic shift right. What that's going to do is divide by 2. And then we'll go back to the beginning of our while loop and check the condition again. And 7 and 5 are not equal, so we're going to do it again. And we're going to spin around in our loop. We get 3. Now some of you might have noticed a problem here. 15 divided by 2 is 7. And 7 divided by 2 is 3. So at no point are we actually going to reach a number here that's equal to 5. So if I just run my code for a while, well, eventually register 0 is going to get down to 0, and it'll keep trying to divide 0 by 2, which is 0, and we get stuck in a loop. So just like in any other programming language, make sure that you don't get stuck in an infinite loop. So let's actually set this to 10, so we eventually get out of our loop here. Alright, here we go. So we have 10, which is not equal to 5. We go to our loop, we divide by 2, we go back to the start. Okay, now 0 is equal to 5, and as you can see our 0 flag has been set here. So this is no longer true. They are actually equal, they are not equal. So we won't take the branch, and we'll go to our rest of the program. Coolio, so we've just done a nice simple while loop. Here's a better way to do a while loop with less branches. Generally, the less branches you have, the faster your program will run. This is often especially important in loops because loops tend to run a lot. So we want to use as few branches as possible. So this is equivalent code to this, just we've shuffled things around so we have less branches. What else? The way this has been shuffled around, sorry, it's actually not exactly the same. We've got a different condition code here. So earlier we were testing whether or not this was true. So our default action, we could say, is to break out of the loop, and we're testing if we stay in it. Whereas when we write our while loop this way, where our default action is to stay in the loop and test if we'll break out. Because if x is equal to 5, then that's our breakout condition, because that will no longer satisfy the condition of the while loop. So yeah, just make sure that you've got your condition codes the right way around. So because our program is that we do the loop while x is not equal to 5, when x is equal to 5, we want to stop doing the loop. So we'll break out of the loop. Okay, so that's what this slide's talking about. And oh, well, I think we answered this question. If x is not a multiple of 5, what will happen? We get an infinite loop. So we've looked at while loops. Now let's have a look at for loops. Now, for loops are a little bit interesting because we're sort of doing things over range. Generally with for loops we have an index and some kind of start and end value and code inside the loop. So we can, once again, we can do this in assembly, and this is what it might look like. And of course, it is roughly the same idea as while. Here's some C code that will sum all the odd numbers under 10. Here it is in a different language, just to show you that we are actually doing the same thing. There's lots of different ways to write it. And oh, cool! I think I have to write this myself, don't I? So let's watch me code. First of all, we'll initialize our index register, and we'll initialize it. Now, I'm going to initialize mine to 1. And, so we're adding odd numbers less than 10. So what might we do here? Less than 10. So we want... Okay, so if register 0 is greater than or equal to 10, we'll break out of our loop. Otherwise, we'll do our loop. Now I'm going to store the result of my for loop in R1. So I'll initialize my register so in case it contains to make sure it contains no garbage. And then what do we want? We want R1. Add R1, R2, we'll put the result in R1, and we'll add R0, 2. Oh, sorry, this comment I'll just put up here. Okay, so what's this program going to do? This is what we wanted to write. Oh, I've cheated a little bit and done it without some things here, but we're going to sum all the odd numbers less than 10. Let's run this in the debugger and see how it works. Okay, here we go. So we'll initialize our registers here. I'll just set them to decimal format. So R0 is our index register for the for loop, and R1 is our result register. So our index is still less than 10, so we'll do our loop. Oh, what happened? Oh, excuse me, I put the wrong bloody thing in here. Assembly will always catch you with silly little mistakes like that. It's just part of the fun. Okay, now I'm adding the right registers together. So we'll add 1. We'll increment our index, and we'll do it again. Compare, it's less than 10, add, increment, loop. So it's a for loop where I'm adding all the numbers that are odd and less than 10, and I'm doing it starting from 1, and I'm incrementing my index by 2 each time. Cool, nearly there. Okay, now my index is going to be greater than 10. So we'll compare, and 11 is greater than 10, so we'll escape our loop. And there we go, we're done. We've added them all up. Odd numbers from 1 to 9, and put them in here. Good stuff. So there are other ways to do loops. If you look on this Wikipedia article, there's a whole swag of ways to do control flow. You can implement all these in assembly. Do while, for example, instead of just while. Iterate over collections. I have no idea what that means. It's probably something over loops or something. Early exits, breaks, and continues. Yeah, like if you know what any of this stuff means and you've done it in another language, you can almost certainly do it in assembly because other languages get compiled down to assembly. Just if you can't work out how to do it yourself, ask your tutor. They'll be able to give you a go. Okay. So what I might do as my parting challenge for this video, in our example code here, so what's this doing? It's using modulo to check if the number is odd or not. Now, I think you can agree that my assembly solution here of just starting at 1, incrementing by 2, so index is always odd, is a more elegant solution than starting at 0, for example, and checking if the number is odd, and then incrementing by 1. But my parting open-ended question to you is, how might you write a function that checks if a number is even or odd? So how might you write a modulo function? So modulo, for those who don't know, if you have two numbers, a and b, let's say a is equal to 5 and b is equal to 3. If you take two numbers and you divide them, for example, you might get a remainder if they don't divide into each other. So a modulo b is the remainder when you divide a by b. So 5 modulo 3, well, 5 goes into 3 once, and then we get a remainder of 2. So any number modulo 2 is going to be 1 if it's an odd number, or 0 if it's an even number. Let's say, like, 3 goes into 2 once with a remainder of 1, 4 goes into 2 twice with a remainder of 0, and so on and so forth. So my challenge to you is to write a function that calculates modulo. So the way you'd probably start this is, we'll say our number is in R0, and so we'll have our, so R0 will contain the number we're trying to take the modulo of, and we'll return in R1. And then what we want is R1 to equal R0 modulo 2. So if you would like a bit of a coding challenge, write this function. Anyway, that concludes the videos covering this first aid's lecture. If you have any questions, please post on the Waddle forums, ask your tutor, even email me. I'm happy to take questions over email. Thank you very much for watching.